Hey, physics enthusiasts, I'm Swati Malhotra and welcome back to my series on mechanics. Right now, we are learning vectors, and this video is all about vector product. The last video, we have done some basic concepts, mathematical expression of vector product. This video is more about the properties and some more uh, results of vector products and numericals as well. So, let's begin with that. Okay, so in the last video, we have discussed about the properties of the basic vector product, its mathematical expression. This video is about the properties. Okay, so the properties of vector product. First is it is anti-commutative. You have learned in scalar product that scalar product are commutative. A dot b is equals to b dot a, but vectors are anti-commutative vector product. That means if you do a cross b and if you change the vector, that is b cross a, you have to put a negative sign here. So this negative sign means it is anti-commutative. And why negative? It has a very simple logic that if this is a, this is b, a cross b, and if you use right hand thumb rule, then your thumb will point upward. So the direction of c vector will go somewhere upward. But if you do b cross a using right hand thumb rule, then from your right hand and your fingers curls from b to a, your thumb will point downward. For b to a, it goes downward, and this would be a c vector. And in vectors, you know, if the direction changes, you have to put a minus sign. So this negative sign is due to change in direction, due to direction change. Okay, so they are anti-commutative. Next is they're distributive over addition. Distributive over addition is basically like your maths. Simply you have to addition, distribute it like a cross b plus c. So you can write it as a cross b plus a cross c. Like you first cross product and then add, or you can add two vectors and then have a cross product with a. It is one and the same thing. And also with two terms like a plus b cross c plus d, and it gives you what? A cross c plus a cross d plus b cross c plus b cross d. It is like this. So it is distributive over addition, and it is anti-commutative. So these are two properties, and now we can check some of its cases like we did in scalar product. So you know that a cross b gives you magnitude of a, magnitude of b, sine theta n cap, and if you only take the magnitude, then you don't need to put this n cap. It is a b sine theta, like that. So now first you can say that if theta is 0 degree or 180 degree, that means the two vectors are either parallel or anti-parallel. Two vectors are either parallel or anti-parallel. Then in that case, this a cross b gives me what? 0, because magnitude of a, magnitude of b, sine 0 degree or 180 degree is 0. So this term is 0, so this whole is 0. So then your a cross b comes out to be 0 for parallel or anti-parallel vectors. Okay, that means if we check in unit vectors, then if you make a cross product of two same vectors, that is I cross I, you'll get 0. And if you take it as anti-parallel, that is I cross minus I, then also you'll get a 0. Similarly, j cross j is 0, j cross minus j is 0, k cross k is 0, and k cross minus k is also 0. This is an interesting thing, that two vectors, parallel or anti-parallel, that means two equal vectors, have a vector product 0. Okay. Next case is if theta is 90 degree. If theta is 90 degree, that means two vectors are perpendicular to each other, or you can say are orthogonal, then what happened? A cross B would be A B sine 90 degree n cap, and sine 90 is 1, so it's simply AB n cap. So it is the product of two vectors and the direction where the vectors go. But interestingly, if you take the magnitude only, then it's simply AB. There is no n cap. And if you again look at an I cap, J cap, and K cap thing, then A cap, J cap, and K cap are mutually perpendicular to each other, right? So if you take the cross product of I cap cross J cap, you will get magnitude of I, magnitude of J, and n cap, and simply n cap. And in the last video, I've already told you that this n cap has a direction perpendicular to both these vectors. That means it is in perpendicular to this plane. So if this plane is xy, that is I cap j cap, this n cap will definitely go to k cap. And if it is like jk, go to I cap. So that means if your I cross j gives you k cap, then j cross k gives me what? I cap, and k cross I gives me what? J cap. And there is a trick to learn that, making a cyclic order. Put I cap here, J cap here, K cap here, then this, I cross J gives me what? K, J cross K gives me I, and K cross I gives me J in positive order. If we go for clockwise sense, in positive order. And you know, as per anti-commutative rule, this A cross B is equals to minus B cross A. So if I make it a I cross J to be like J cross I, so I have to put a minus sign here, then it comes a minus K here. Similarly, if this J cross K is what? I, so K cross J gives me minus I, and last it was K cross I, so K cross I was J cap, then I cross K is what? Minus J cap. So it is like in reverse order, that is I cap, J cap, K cap. If you move it I to K, K to J, J to I, you will get a negative here. That is for anti-clockwise, you get a negative sign here. So you can remember it with this symbol. This one is important rather than remembering the rule, or if you can remember, then also it's fine. Okay, it's not working. Wait. Okay. Okay, now let's see some of the standard results of vector product. Some standard results. You can use these results to solve MCQs and sometimes in numericals anywhere. So we were going to see these results and their proof, and either you can remember the concept with proof or you can just remember the result. So first is, if you take two vectors a and b, and if you first subtract it and take a cross product with a plus b, then that comes out to be twice of a cross b. Okay, so the proof is, you can simply use distributive property. It's a cross a plus a cross b minus b cross a minus b cross b. Now this, okay, the first is a cross a. So this a cross a goes to 0, b cross b goes to 0. So it remains a cross b, and b cross a can be written as a cross b. And that is equals to twice of a cross b, which is my standard result. So you can remember this and the concept. If we interchange it, let's say if I am using a plus b cross product with a minus b, a minus b. So in that case, if I am interchanging my two vectors and taking a cross product, then as per the anti-commutative rule, there should be a minus sign. It should be minus twice of a cross b, and that can be written as b cross a. Okay, so there could be some trick of plus minus in MCQs to check your concept. So just remember that thing. Okay, just remember these two things. The second one is it's a cyclic one. If you take three vectors a, b, c, then a cross b plus c plus b cross c plus a plus c cross a plus b, that is equals to 0. You can simply check the proof. It's something like cyclic thing. Okay, like a, b and c. First a, then b cross a, then b c cross c plus a, and so on. So if you check the proof, it just use distributive property. First is a cross b, then a cross c, then b cross c plus b cross a plus c cross a plus c cross b. Now this a cross b and b cross a can cancel each other, because this can be written as minus of a cross b as per anti-commutative property. A cross c and c cross a cancel, this cancel, and it comes out to be 0. So that's the cyclic property. The third one is an interesting one, an important one. It is basically the relation between cross and dot product. Cross and dot product. So it is like a cross b whole square is equals to a square b square minus a dot b whole square. You have to remember this. This is an important one. You can also check the proof here. First, for a cross b, what you can do, just take the magnitude. Magnitude of a and b A cross B magnitude in square. So the magnitude of A cross B is A B sine theta, and just square it. Then it become what? A square B square sine square theta. Okay, and that sine square theta can be written as what? 1 minus cos square theta. And if you multiply it, it become A square B square minus A square B square cos square theta, which is a dot product. So this become A dot B whole square, because A dot B is what? AB cos theta, magnitude of A, magnitude of B cos theta. So A cross B whole square comes out to be magnitude of A square, magnitude of B square minus A dot B whole square. The important one. Okay. And from the relation between dot and cross, there is one more thing, the fourth one, to prove three vectors A, B, and C are coplanar. That means they lie on the same plane. So if A dot and B cross C comes out to be 0, or B dot A cross C or something, then it is coplanar. The proof is not mathematical, it's more conceptual, theoretical. It is like, if they are coplanar, that means that is they all are in same plane. But we know that this B cross C gives me a vector which is perpendicular to both B and C. So if A are in plane with B and C, then its dot product will give me 0, because then the angle becomes 90 degree. So, okay, so let's do some numericals on that. So my first numerical is, let's take determinant of A to be 2. Sorry, magnitude of A to be 2 and magnitude of B to be 5, and A cross B is taken as 8. And we have to find A dot B. So we have seen the relation that A cross B whole square is equals to A square B square minus A dot B whole square. So we can use that. A cross B whole square is equals to magnitude of A square B square minus A dot B whole square. This is 8 square. A is 2 square into 5 square minus A dot B whole square. Sometimes they also ask cos theta. Okay. So it is 64. This is 2 to the 4. And 5 is 25. This is 100 minus A dot B whole square. So A dot B whole square is equals to 100 minus 64. That is equals to 36. And A dot B comes out to be 6. Okay. And then you can use A, B cos theta is equals to 6. A and B are what? 2 and 5. That is 10 cos theta is equals to 6. So cos theta comes out to be 3 by 5. Okay. So you can find the angle as well. The next question is, find the area of the triangle, but with a twist. What is the twist? That you have given the edges of the triangle. Find the area of the triangle formed by the tip of the vector. Formed by the tip of the vector. Okay, so that means you have a triangle and you have the vectors of their tips. This is A, B, C, where your A vector is I cap minus j cap minus 3k cap. B vector is 4i cap minus 3j cap plus k cap. and your C vector is 3i cap minus j cap plus 2k cap. So you have this, and if we need to find the sides, because to find the area we need these sides, two adjacent sides. That means I need AB vector and I need AC vector. So for AB vector, it's from A to B, so we have to solve it for B minus A, and for AC it's C minus A. Okay, so let's do B minus A. That 4 minus 1, 3i cap, minus 3 plus j, minus 2 j cap, plus k, and plus 3 plus 4k cap. And AC will become C minus A is 3 minus 1 is 2i cap, minus j and plus j will gives you 0, j cap and plus 2, and minus minus plus 3 gives you plus 5k cap. Okay, it's simple maths. And then you have these two vectors as the adjacent sides of a triangle, and their cross product will give you the area of triangle, means is equals to twice the area of triangle. Okay, so first we have to calculate this AB cross AC. Okay, so wait a minute. Okay, let's calculate this AB cross AC. AB is, first you have to write I cap, J cap, K cap, then 3 minus 2, 4, and 2, 0, and 5. Okay, and then just cross multiply. For I cap, it's minus 2 into 5 is minus 10, 4 into 0 is 0, then minus J cap, 3 5s are 15, minus 4 2s are 8, then plus K cap, 300 plus 4. This gives you minus 10 I cap. 15 minus 8 is 7, so minus 7 J cap, and 0 plus 4 is 4K cap. And then we have to find its magnitude. So its magnitude is 10 square is 100 plus 49 plus 16, 9 plus 6 5, carry 1 6, 165. So the area of triangle comes out to be half root 165 square units. Okay, let's do one more numerical, the last numerical. In this you have to find the area of parallelogram, and you are given the diagonal, that is the diagonals of parallelogram are given as 3i cap plus j cap plus 2k cap and I cap minus 3j cap plus 4k cap. Find area of parallelogram. Find parallelogram area. Okay, so now here you have given the diagonal. So the trick is, like, this is a parallelogram. This is A vector. This is B vector. Okay, and you have this one diagonal. Let's say D1. Now this is also be my B vector, and this is what? My A vector. And let's take another diagonal to be like this. Okay, so from here the triangular law uh, in this triangle, in this particular triangle, comes out to be what? A B is equals to D. That means A vector plus B vector gives me what? D1. Okay, and the second one you can look for this D2 in this particular triangle. Okay, And for that, it's like this is B, but A is an opposite, and you give this D1. Okay, this D2, sorry. So it's like B vector, but A is an opposite minus A vector gives you what? D2. Okay, so you are having two equations. A plus B is equals to D1, and minus A plus B is equals to D2. So if you first add it, you will get a B vector. B you will get by adding these two equations and divided by 2, just the linear equation, that is these two A and cancel, this is 2B and D1 plus D2, and you shift to there. And then for A you have to subtract it, but a minus and then B will cancel, so it becomes half of D1 minus D2. D1 minus D2. So the B vector so the B vector is equals to half of, you add both the diagonals, 3 plus 1 4I cap, then plus j and minus 3 is minus 2j cap, then plus 2 and plus 4 is plus 6k cap, and half gives you 2I cap minus j cap plus 3k cap. Okay, and for the A vector you have to subtract both the diagonals components. 3 minus 1 is 2I cap, then plus 1 and minus 3 gives you plus 4j cap, and then plus 2 and minus 4 gives you minus 2k cap, and half it become I cap plus 2j cap and minus k cap. Now you have two vectors A and B, you can simply make a cross product and then take its magnitude. So A cross B is equals to what? I cap, j cap, k cap. First is 1, 2, minus 1, and this is 2, minus 1, and 3. And now take its determinant. This is called basically the determinant. We take determinant when we cross multiply the components. That is 2 3 is 6, minus minus is plus 1, the minus 1. Then minus j, 1 3 is 3, then minus 2, the minus here gives you plus 2. And then it's plus k cap and minus 1 and minus 4. Okay, so that comes out to be 6 minus 1 is 5 I cap, 3 plus 2 is 5 j cap, and then minus 5 k cap. Okay, so that is cross B. And if you take, sorry, and if we take its magnitude of A cross B, then it is what? 5 square 25 plus 5 square 25 plus 5 square 25 gives you root 75. That is the area of parallelogram. Okay, so this is how you calculate the area of parallelogram and area of triangle. So this is much for today's video. In the next video we'll do some MCQs and then the numericals, and we'll learn some more concept, but the major portion of vectors completed here. So in the coming videos we are going to do more numericals and build more concepts. Okay, so thank you for watching this video, and do like, share and subscribe for more such videos.